In this video, I am going to go over the relationship between rate, time, and distance. So let's just jump into an example problem. Let's say you're riding your bike and your average speed is 9 miles per hour. And sometimes I interchange the words rate and speed. But what this means is that every hour you cover 9 miles or you travel 9 miles. And let's say you spend 3 hours on your bike. How could I figure out the distance traveled? How could I figure that out? Well, I spent 3 hours on my bike, so in 1 hour I cover 9 miles of distance. But I do this 3 times because there's 3 hours, so it's 9 miles plus 9 miles plus 9 miles, right? Hopefully that makes sense. I'm using repeated addition. 9 miles in the first hour plus 9 miles in the second hour plus 9 miles in the third hour. So a total of 3 hours here, and 9 miles plus 9 miles plus 9 miles is 27 miles. So that would be my distance covered. Well, hopefully you can see there's an easier way to do this instead of repeated addition. You can simply take the rate, which is 9, and multiply it by the time, which is 3. And when I take the rate times the time, I will get the distance, because 9 times 3 is 27. And that's where this formula comes from. The distance equals the rate times the time. Maybe you've seen this before. It's usually written like this: D equals RT. So I just wanted to go over that so you know where this formula is coming from. Let me clear this out. I'm going to rewrite the formula here. Distance equals rate times time. But I'm going to show you a model to help you with this formula. I'm going to make a little triangle here. And I'm going to put my D here for distance, my R here for rate, and my T here for time. And this is going to help you with the problems I'm going to go over in this video. So let's say, for example, my speed or the rate is 10 miles per hour. And the time is 4 hours. And I want to find the distance. Well, in this table, when the numbers are right next to each other like this, you multiply them together to find the distance. In other words, you're going to take the rate times the time. 10 times 4 is 40, so my distance would be 40. Let's say it was set up like this. Let's say you were given the distance of 50 and the rate was 25. And you wanted to find the time. Well, when the numbers are on top of each other like this, you divide. So in other words, you're going to take the distance divided by the rate to get the time. So this kind of serves as a division symbol right here. So I go 50 divided by 25, and I get 2. Or it could show up like this. You could be given the distance and the time. Maybe the distance is 100 now, and the time is 25. So the numbers are on top of each other. You will divide. So in other words, to find the rate, you take the distance divided by the time to get the rate. So 100 divided by 25 is 2. This little triangular model is really going to help you figure out when to multiply and when to divide. So in short, let me just summarize this. If you are given the rate and the time, and you want to find the distance, you would multiply the rate times the time, because these numbers, whatever they happen to be, would be right next to each other. Multiplication. If you're given the numbers here and here, to find the time, you would take distance divided by rate. You take whatever this number is divided by this number to get the time. And if the numbers show up like this, again, you would use division. You take whatever this number is divided by this number to get the rate. So let's look at some problems here. I'll make up some more numbers. Let's say that time is 7 hours and the distance is 161 miles. So in this situation, I'm looking for the rate. So the R here, we'll just leave that blank. And the time is 7 hours. So I'll put the 7 here in the time slot where it says T. And the distance is 161 miles, so I'll put the 161 where the D is for distance. Well, I have two numbers on top of each other, so I'm going to take 161 divided by 7 to get the rate. In other words, to find the rate, I'm taking the distance divided by the time. So 161 divided by 7. And that gives us 23. So the rate or speed is 23, and it's going to be miles per hour from right here, miles per hour, mph. Let's look at another one. Let's say the speed is, or the rate is 14 miles per hour. And the distance traveled is 42 miles. How could I figure out the time? Well, let's just plug the numbers into this little diagram. So 14 is the rate that goes here. The distance is 42, which goes here. And we have two numbers on top of each other, so to find the time, I'll take the distance, 42, divided by the rate, 14, to get the time. So 42 divided by 14 is 3. So the time is 3 hours. And all the units for the problems I'm doing now are in miles and hours. I mean, you could have problems where instead of it saying hours, it might be miles per minute or something like that. Let's look at one more. Let's say the rate is 65 miles per hour, or the speed, and the time is 7 hours. What would the distance be? Well, the rate R is here, so I'll put the 65 here. I will put the time here for T, so the 7 goes here. I need to find the distance, so when the two numbers are right next to each other like this, you multiply. In other words, you take the rate times the time to get the distance. That's exactly what this formula says. So let's go 65 times 7. 65 times 7. That's going to be 455. So the distance traveled is 455 miles. Let's look at some story problems. Let's say we have the following problem. It says, when you ride your bike, your average speed is 9 miles per hour. Today you travel 63 miles. How many hours were you on your bike? Well, this is a distance equals rate times time problem, right? So let's make our little diagram here and fill it in. D goes here for distance, R here for rate, T here for time. Now, I like to underline the final question. It's asking us, how many hours were you on your bike? That indicates we're looking for the time in hours. So this is going to stay blank right here. So we need to fill in the numbers for distance and rate. So let's see, does it give us that? It says right here, your average speed, right, is 9 miles per hour. Speed, when you see that, you'll put that into the rate box right here. So the rate or speed is 9 miles per hour. So I'll put a 9 right here. Okay, and it says today you traveled 63 miles. That's your distance. Distance is measured in miles, so I'll put the 63 here. So what do I need to do here? I'll take the distance divided by the rate to get the time. When it's written like this, remember, you divide. And 63 divided by 9 is 7. So how many hours were you on your bike? 7 hours. Let's look at another problem here. It says several students are going to ride their bikes from the city park to Lake Kaganza, a distance of 25 miles. They will ride at an average rate of 10 miles per hour. What is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? Again, this is a distance equals rate times time problem, right? So let's set this up. Like so. D, R, T. Now it gives us some information here. It says they're traveling from the city park to the lake. And it's a distance of 25 miles right here. So let's put 25 in for the D, for distance, right here. It says they will ride at an average rate of 10 miles per hour. That's right here. Rate 10 miles per hour. So for the R here, I'll put in the 10 right here. Well, I need to figure out the time, right? So I need to take the distance divided by the rate to get the time. So I'll go 25 divided by 10. And that's going to give us 2.5. So it's going to take him 2.5 hours to get from the park to the lake. I'm going to write in the hours here, the unit. And I know it's hours from right here. The word hours is right here. Well, there's a little twist to this problem. So I'm going to clear this out and just write this piece down right here, that the time is 2.5 hours. In other words, from the park to the lake takes them 2.5 hours. Well, hopefully you know that 2.5 hours is the exact same as 2.5 hours. I mean, think about it, 2.5. If this were money, right? I could rewrite it as 2.50. And $2.50. Well, the 50 cents is a half a dollar. So this is just like $2.50. Maybe that helps you see why these two are the same. So in other words, the time is 2 and a half hours, well, that's the same as 2 hours and 30 minutes. Because a half of an hour is 30 minutes. So if they want to arrive to the lake at 11 a.m., when did they need to leave? I need to go back 2 hours and 30 minutes. So let's just go back from 11 a.m., 2 hours and 30 minutes. So 11 a.m., 10 a.m., 9 a.m., and 30 more minutes would be 8:30 a.m. So this is my answer right here. It says, what is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? Well, they'll need to leave the park at 8:30 a.m. to arrive at the lake by 11 a.m. And you can double check it. If you add 2 hours and 30 minutes to 8:30 a.m., you'll get 11 a.m. Let's just do that real quick as a double check. 8:30 a.m., 9:30 a.m., 10:30 a.m., plus 30 more minutes is 11 a.m. So my answer is 8:30 a.m. A little tricky, this last problem. Hope that made sense to you. And as always, thanks so much for watching my videos. Have a super great day.